Welcome back to the Code Wolf. Let's jump right into the demo app for today's video, since I think this is one of the cooler sample apps on the channel. We'll get into how this app works and how you can get it set up on your own more in a little bit, but for now, let's just see what this app actually does. So this app is called Image Hunter, and as you can see at the top, it says enter a prompt to search your images, so whatever images you upload to this app. And the search is AI powered, so you can just enter whatever natural language you want that describes what you're looking for, and it will find relevant images. And this is not using the file name or description or tags or anything like that. It's using vector embeddings and running vector searches for similarity. We'll learn more about what that means and how that works in a second. But let's just start with some examples here. So we could say something like cake, and sure enough, we get 3 pieces of cake and a cupcake back. So maybe we want to be more specific and we'll just say cupcake. And it looks like there's actually more cupcakes in the database, but this is returning the most relevant results. So we could say something like lakes, and there's some nice lakes, or we could say trees. So whatever term you can think of, you can plug in here and it will return relevant results. However, because this is vector search enabled, we can enter in much more than just keywords or certain terms. So I could say something like capable of flight, and at first you'll see that there's no relevant results, but that's because of this setting over here called the confidence threshold. So this essentially tells the app how sure it needs to be about the results before it will show them. And by default, it's set to high. But if I were to switch this to medium, that will allow slightly less confident results from the vector search to come back. So now we'll get a couple of airplanes here because it understands the contextual meaning of our search term in the context of these images that it has analyzed. We'll get into all that in a minute. And we can go even further with this. So we could say something like on a plate. And these are all definitely on some kind of plate. To be fair, this first one's on a cutting board or something, but close enough. And we can also filter the number of results that come back. So I'll just pick something with a lot of results. So here's coffee. And it finds 10 pictures right away, which is cool in itself. But if we increase this to 15 or even 20, and we run our search again, now you can see that there's 16 images, it looks like. So there's 16 that met the threshold of medium. And if we switch this to high, that drops down to 12. So you can kind of play around with this count and with the threshold. So if we set this all the way to low, then there's, it looks like 20 or so. So we get the full 20. And we can just keep searching here for different things. So if I were to search for baked goods, and I'll bump this back up to high, you can see that it comes back with 5 results, and it's kind of a mix of different baked goods, and we can just kind of play around with this and we get different results. So this search is super powerful, and it's all just based on contextual meaning and phrases and whatever you want. Now, we can also, of course, add more images to this. So if I were to open up our images folder here, and I'll just drag and drop these 2 images, a stop sign and some pumpkins, and I'll drop those in, and I'll say upload. And it's going to think about that for a second, and we'll get a notification that that was uploaded successfully. And now right away, if I were to search for pumpkin and hit enter, you can see we actually get 3 results. So we get a pumpkin patch kind of out in nature, we get pumpkin bread, and then it must think that this is pumpkin coffee or foam or something like that. So let's bump this threshold back up to high. And now when we search again, we just get actual pumpkin. So hopefully this gives you kind of an idea of how this search works and how it prioritizes and thinks about things. And when you upload it, those are immediately available for semantic search. Okay, so you've seen the app, but there's a lot more to talk about here. This video is intended as the first in a series of videos about working with AI and images. If you follow my channel, you might already know about the dbChat Pro app for using AI with relational databases. Well, this series is basically going to be the images version of that. Now, the rest of this video is split into 3 timestamped sections to explore version 1 of this app in more depth. So first, we'll review how the app works conceptually by walking through a couple diagrams. Second, we'll step through the general process of how to get this app set up yourself and discuss the prerequisites required to get it running on your computer. And finally, towards the end of the video, we'll dive into the code itself to explore the logical flow and critical components. Remember to click that subscribe button to stay tuned for future videos and to support the channel, and let's get started. Okay, so now let's take a look at how this app works conceptually using a couple of workflow diagrams. And let's start with the image upload flow. So when the user uploads an image in the browser, like we saw in the demo, that image will get sent over to the app backend and it's going to start processing that. And the first step there is that the app will save the image to the www directory, and that will allow the app to serve up that image again if it's requested by the browser. So if the user searches or wants to see that image again later, our app can actually return that file. Now, the second step here is to take that image and send it to a specialized type of AI model for vectorization. So the AI is going to create a vector embedding of that image. And a vector embedding is essentially a numerical representation of the context or meaning of that image or text or whatever you send it. And so all the numbers in these embeddings exist in vector space. And different AI models or specialized types of databases, they can measure sort of the distance between those numbers to measure similarity or relationships between these different numbers or these different pieces of content. So vector embeddings just capture the meaning of our data and provide a way for these systems to perform analysis and comparisons of their meaning. And so the last step here is to take that vector embedding or that vector data and save that into a vector database. And then later we can run vector queries against that data to look for similar results. So once the image is uploaded, it exists in a directory where it can be returned to the browser, and the associated vector data is saved to a database for similarity queries later on. So speaking of those queries, for the image search flow, the user is going to enter a search prompt into the browser and then submit that, and the app will receive that on the backend again. And then it's going to take that prompt from the user and it's again going to send it to that same AI model for vectorizations. So in this case, the AI will create a vector embedding for that text content that captures the meaning or context of that text. And this does need to be the same AI model that generated the vector embeddings for the images so that they are comparable and that they work well together. So then we can take that generated vector embedding of the user's search prompt and run a vector search against the database. So remember, this is the database where all of our image vector data is stored. Well, now we can take that vector embedding for the text prompt and compare that and run similarity searches against the vector data for the images in the database. And so the search will return a set of results, as many as you specify, and those will be sort of ranked by how confident it is about the similarities or how closely they are related. So that's going to be a score. And then we can use that score to influence behavior in the UI, like what we saw with our high, medium, and low thresholds, and the limit of the number of results returned and all that. And so after that page data is rendered with all of the image tags that contain the most relevant images, then the browser is actually going to request those images from the web server again. So it's going to retrieve those raw files and those will get displayed in the browser. So user sends a prompt, prompt gets vectorized by the same AI. That vector embedding of their prompt is used to run a vector search. The results of that are sent back to the browser, and then the corresponding images of those results are loaded from the server as well. Okay, so now let's go through the steps on how you would get this set up and running on your own computer locally. Now, I'm going to assume that if you're watching this, you're comfortable with some general development tasks like cloning GitHub repositories, starting up a container using Docker, and provisioning a basic cloud service. And we'll walk through these, but it's not going to be a super in-depth look at each step. So if you go out to GitHub, there's this AI image search repository, and I'll put links to all these different pages in the description. But go ahead and clone this down. So you can either do that with Git using this URL, or you can just download this as a zip if you don't have Git installed. But the clone is really the easier way to go. And I'll try to add a README with these steps. Right now, at the time of this recording, that's not available, but I'll try to make that available. And this app is built using .NET. So you'll need .NET installed, specifically .NET 9. So I'm using the latest version here. So you'll just click this download button. It's a pretty standard install process, so I'm not going to walk through that step by step, but you will need this installed on your computer. Now, one of the main dependencies for this app is an Azure Computer Vision service, and there is a free tier, so you shouldn't have to spend any money for this to work. You'll just need an Azure account and be able to get in here. Computer vision is really powerful in terms of generating embeddings and analyzing images and doing all kinds of things with very minimal work on the developer's part. So you will need an instance of this service for the app to work. Now, creating one is pretty simple. You just have to pick a resource group or create a new resource group, and then your region and a name for the service. And for the pricing tier, just make sure to select the free option. I'm already using the free option on this account, so I can't create another one. But this allows you, I think it's 20 requests or 20 embeddings per minute and a few thousand per day for free. I would double check the full pricing details for whenever you're watching this video. But at the time that I was using this, it was a pretty decent free tier, at least for a simple demo app like this. So you'll need to create this service. And then once you fill out just this one page, you can just click review and create and then go from there. After you've created the service, you'll just need to go down into the resource management and select keys and endpoint. And then you'll need to copy your key. And that's because in the app, you'll need to plug it into the program.file. So you'll have to open up the program.file. And there's this placeholder for your key. So I should probably mention that after you download this from GitHub, you'll just want to go down into the root folder, and then you'll double click on this imagehunter.cs proj file if you're using Visual Studio, or you can open up this whole folder in VS Code. But once you have the app open here, you'll just need to plug in that computer vision key, and then you'll also need to plug in the URI to the service. So over here, you'll just copy this endpoint. And so those are the two values you'll need. Keys are secure, so don't share them. I've deleted mine here and just replaced it with this placeholder. But those are just the two values that you'll need there to hook up your Azure service. Now, the last dependency is Qdrant. And Qdrant is a vector database service, among other things. But you can run it locally as a container. So even if you don't know what Qdrant is and you don't have it installed, that's totally fine. You'll just need to run a command with Docker Desktop running. So you will need Docker Desktop installed if you want to run this as a container. But that's a pretty common development tool, so I'd recommend having that installed anyways. So back in our command prompt, this is the command you'll need to run. I'll just zoom in here. I'm just telling you this command, so if you're not that familiar with Docker, you can still get this running. So this is going to pull down that container. We're going to open that on these two different ports for different Qdrant features to work. And we'll name that container Qdrant. And that's going to be the Qdrant/Qdrant image. So a lot of Qdrant here. But this command will get that running. And once that's running, you can verify in Docker Desktop that that is running. And if we visit this localhost 6333/dashboard, that'll take you to the dashboard for Qdrant, and then you'll be able to see that it's running. So once this is up and running, you'll be good to go as long as you've plugged in your keys and your endpoint for your Azure service. The localhost Qdrant URL is already added to the app, so you don't have to worry about adding that one yourself. Once all of that is in place, you're going to run the app using this green button at the top here. Or you can also start the app with the .NET run command from a terminal or some other text editor at the root of this project. So in this folder here, we could just open up a command line and run the .NET run command. So I added my key and I ran the app again. And it's worth mentioning that when this page loads the first time for you, it will just be blank since you won't have any images loaded. And at that point, you can start dragging and dropping your own images or whatever images you can find and upload those, and they'll start getting vectorized using Azure and saved in Qdrant, and then you can start using the app. Now let's walk through the actual code of this app to get a better idea of how it works. Now for this part, I'm going to use VS Code just because it's a bit easier to kind of zoom in and out, and we already glanced at Visual Studio before, so let's just kind of use this to explore the code base here. Now this app is built in .NET, and whenever you first open up a .NET app, a good place to start to see how everything is set up is always in the program file, because there we can find our injected services and some core configurations and things like that. So if we look at our services here, we are using Blazor in this app. So that's a powerful UI component library for Blazor. I really like Blazor, so I built the UI using that. And then we're adding an HTTP client for dependency injection. So we'll be able to get a client in our different Blazor components and make calls to our Azure service and to our database and so on. And down here, we have two services registered to do just that. So if I zoom in here a little bit, we have a vision service that goes out to Azure to vectorize our data, and we have a database service to manage querying and saving data to Qdrant. And we'll look at these services more in a moment. But those are kind of our main pieces here for the UI to work and for all this to come together. And the rest of this is just pretty standard boilerplate .NET app code. So over in our home component, this is where most of the magic happens for the app. So at the top, we just pull in the namespaces that we're using from our packages, and then we inject our services, including the ones we just looked at in the program file. And then we get into our UI here. And I've tried to add as many comments as possible to kind of explain the structure as you read through here. So we have our search form and our upload form, and these correspond to the diagrams we looked at. So first, let's look at our upload form. Now, because we're using Blazor, some of this looks very verbose or more scary than it really is. A lot of the Blazor UI components just have a lot of properties that you can fill out to customize things, but this is just a file upload component. And really the most important part of this is this activator content. So this is where we see those images listed when we select them for upload, and this kind of activates some of the functionality here. And then down below that, we have our buttons here where we actually click to upload or clear the file upload. This is actually just a pretty standard Blazor file upload with multiple file support enabled. So there's nothing too crazy here. And then when we click that upload button, so this middle one here, this is the upload button. So when we click that, we're ultimately going to end up in the upload method here. And again, I've put comments to kind of walk through the step by step. So if we click this upload button here, eventually we're going to end up down in our upload method. So if we expand that, I've also tried to add in comments here so we can always follow the flow. But basically we're going to loop through each of the image uploads. So the files we selected get bound to this image uploads list. And then for each of those, we basically just complete the steps that we looked at in the conceptual flow diagram. So first we construct a folder path and save the uploaded image there. So we're just using some utilities here in a file stream. This is all pretty standard .NET stuff. We just save our folder to that path. Then we have to go out and vectorize our image. So for this, we're using a memory stream and copying the uploaded file into that. And then we use our vision service to vectorize the image. So this vision service.vectorize image, that's what's actually going to go out to Azure. And if we go to our implementation here, you can see that that's just building a standard HTTP request. It's going out to the computer vision URL here. That's pretty standard for that Azure service. And we're just setting some content types. I'm using a very manual approach to building up an HTTP request here just because we're customizing some different things and we're working with a byte array and so on. But eventually we do use our client to send that to Azure. So this method is essentially just a wrapper around an HTTP client request to Azure, sending our image bytes along. And that's going to return our vector. So the vector data comes back from Azure. And that means back in our original home component here, we can take that vectorized data and we save that to the database. So this is using the vector DB service. Before we were using the vision service for Azure, but now we're saving our images to the database. And so we can go into that implementation. And it's kind of a similar deal here where this is just a wrapper around the operation to insert that into the database. So we're taking that vector data up here and we're constructing a Qdrant point struct. So this is just the format that Qdrant wants that data in. And then we insert that into the database. And that's really all there is to it. And so if we head back to our home component here, you can see that's pretty much the end of the method. And then we just give a snack bar notification or that pop-up window to say that that was successful. And we also display an error snack bar message if it was unsuccessful. And finally, update our UI and retrieve the new set of images. So this vector DB service, this get all images, if we go to that implementation, this is just querying the database for all images, up to 100 of them. You can set that to whatever you want. Whenever we update which images have been uploaded, we want to re-retrieve the images to make sure it's displaying all the latest ones. Now in a production app, or if you're working with a ton of images, you might want to change how that works a little bit for performance reasons, but for simple scenarios like this, it works just fine. So that's our upload. And so let's collapse that. And now if we go back up to our UI here, let's take a look at this search form. So this is the other flow that we looked at in our diagrams. And this is just using an edit form component. So pretty standard Blazor form stuff here. So we have our text field. So this is where the user actually enters in their prompt. So all the different form inputs are being bound to our model. So our search prompt is what they actually type into the text bar. And then we have a loop here to build out the number of items that get returned. So that's our result limit. and that goes up to 25, but you can change that to whatever you want it to be. And below that, we have another drop down for our confidence threshold. So if you remember that, where we can pick like high, medium, or low, all of this data is just getting bound to our model. And so our model that's defined up here on our edit form. And so that model represents the different data fields here that we can bind to. Now, when we submit this form, that's going to take us down to search images. So if we expand this, it's very similar to our upload flow. So first we vectorize the prompt this time instead of the image. So the search prompt here on our model, that gets passed into our vision service.vectorize text. So if we go to that implementation, it's pretty much the same thing as our vectorize image, but for a text request, we're actually going to be sending JSON. So we're doing kind of a JSON serialization here on that text prompt, and it's actually going to go to a slightly different endpoint. So this is vectorized text over here at our URL, whereas this was vectorize image. So we're just kind of changing the content types and the endpoints, but it's enough to justify a different method. So we have vectorized text and vectorized image. And then if we go back to our home component here, we'll get that vector embedding back from our model. So we store that in a variable, and then we use that to perform a search. So on our vector DB service, we're saying search images, and we're sending in our vector data for the user's prompt. So if we look at that method, this is just a really simple query to Qdrant, where we're saying query the images collection, use this vector data, and limit the results to whatever they picked in the UI. And this is the part I really want you to focus on here. So a vector search is not the same as like a SQL search where you manually specify this really long query with different syntax. You simply provide this vector data, and it's able to just run a comparison analysis of that vector data against the items in the database, and then it brings back X number of relevant results depending on what you specify here as the limit. So really just this 4 or 5 lines of code creates a very powerful search for our app. And then when we go back to our home component, we can store those returned images in our searched images variable. And this last part is really interesting. This is where we're actually grouping them by confidence threshold. So all of these images come back with a score, and then we check if that score is above the confidence threshold that they picked. And if it is, then we select those images and convert them to a nicer type to work with, and then we return those to the UI. And then all of this gets set as the images variable, which is what's rendered out in the UI. So if we scroll back to our UI up here, on these search results, you can see that we're looping through each of those images that were returned from the database, and we build out an image object with the image path defined. So when these actually get rendered in the browser, they'll request the image file on the server and it will provide that for us. So that's kind of a high level overview of how this code works. This is really designed for you to kind of dig in here and mess around with it and change things and just kind of experiment and see how all of this works. So thanks so much for watching. Please remember to subscribe or support the channel somehow, and I'll see you next time right here on the Code Wolf.